Welcome to our presentation on the solution family approach to defining the next generation of intelligent devices and looking at the solution family architecture for creating those new devices. The solution family is two things. It's an extensible engine that runs on the devices, and then a complete set of development tools that enable us to create intelligent devices that create, collect, aggregate, and cloud publish data, as well as define and assume new behaviors with all the solution family features applicable to all markets. Again, everything you're about to see and the demonstrations use the same tools on all the different verticals. Solution Family is a product created by a collaboration between real-time development and OpenNetCF. Together we have over 50 years combined development experience, and for the past 12 years real-time development has been developing Solution Family, created originally on U.S. Army flexible explosive manufacturing projects. But Solution Family and the tools were all created as an integration tool for the engineers working at real-time development as their key integration capability. And after many years of working on those tools, we finally bring those to market. We demonstrated 24/7 operation in hundreds of applications over an entire decade. We've fielded applications with less than $700 bill of materials with complete industrial solutions. Customers, U.S. Army, General Motors, Mitsubishi, General Dynamics, some Latham, Thermo Fisher, 3M, and Akuma. The challenge is to define and create intelligent devices that allow us to understand, monitor, understand, and improve any software hardware integrated system. So that's the challenge, and our solution was to create intelligent devices using a robust engine running on the device, and then have development tools that are architected for the flexibility and extensibility required to address a variety of applications. So again, these aren't point solutions, these aren't tools that are just created for one particular vertical. The goal was to create this flexible engine and tools that can control and define what that flexible engine is going to be doing. Markets that we've applied the solution family over are, we started off in process control, looking at processes within manufacturing plants to look at the recipes they use to be able to define what's going on in order, quote, a recipe around a particular production process, and then look at machine tool controls so that we can go and look at doing a better job of cutting the part that we're currently working on, having more information, more intelligence. Then we looked at security systems, and we're implementing security systems that allowed us to have the security system have various behaviors when they're looking at securing a particular facility, in building automation, intelligently be able to control boilers or heating systems and cooling systems within buildings to be able to try to minimize energy cost using the latest technologies. And finally, in telematics, looking at intelligent control and monitoring of vehicles so that we can provide information both to the maintenance personnel, routing information, and all of that in telematics, all with the same tools. Again, this engine you see at the bottom of the screen here, and the development tools that run above it. So we want to start off by defining what an intelligent device is. Everybody uses it all the time. But the intelligent device to us has the following capabilities. Has the ability to manipulate data, so we can create and aggregate and collect data. So if we have data on the device or getting information from I/O on the device and we want to create some information from that, we're processing information. We want to be able to support rules, so we can define behaviors of the device, not just getting data and moving it back, but we want to have the device do something about that. And then also, always in context to knowing that you're occasionally supported, so the device has to be able to do local storage and then be able to get that information back off the device. And extensible, make sure that the device is extensible with new I/O systems and models, and that has to be part of the natural architecture of what's running on the device so that we don't have to throw everything away if we want to add some capability to it. And make sure that device knows how to store either to the local cloud or to locally to its own storage, or to the cloud as a storage mechanism. So again, that's the definition of what an intelligent device is. Our solution family approach says that we create an engine that runs on the device and then tools that do that. So let's take a look first at the architecture of the engine. The engine supports the interrogation and analysis and improvement of any hardware-software integrated system. It exposes all services and features via REST interfaces. And vertical application expansion is allowed to happen within modules and or adapters within the engine. So the engine has a natural mechanism for doing that. The source code targets natively Windows CE through Windows Server, any Windows OS, and has native support for Azure Cloud through table services, and targets via mono both Android and iOS. The solution engine will look at it from the ground up. We use .NET 3.5 for the solution engine. It uses a database with a storage module plugin, so you can use SQLite, SQL CE, Full SQL, and then a web server called Padarn, developed by OpenNetCF, and this gives us a web server that can run on the smallest devices the whole way up, and that web server allows us to be able to do this REST communication. There's a layer called IOC, which you can just think of as a way for services to register themselves and for different modules that we're going to talk about in a minute to be able to gain access to services and other modules. ORM, which is a way to store objects, and we could just have a single line of code that says, hey, this object I want you to store right now, and it'll open up a database table and stick that data for that object in there, and then the next time you store that, it'll make a new row within that table. The solution engine that lives above those 5 services, its job is to basically handle getting data coming in and out of the device and handling service requests to be both get and set the data, and then be able to load modules and adapters and allow those modules to register themselves to the web server. So the solution engine's job is to then look at the modules that you have described in the manifest that need to be loaded. Module's job is to support services that will run along with the solution engine. So if we have a temperature service, which allows you to define all the temperatures that you want aggregated together and look at some statistics based on that, then that would be in the temperature service. It would also, for the control of that service and the configuration, it would be able to publish a handler out of that temperature service that would be registered with the Padarn web server. So module's job is to create services and handlers that and register them with the web server. And finally, adapters. Adapters' job is to take data coming out of any of the modules in the solution engine and be able to get it and feed it back to the user. So if we have XP, which is Digi's version of Zigbee, and we're looking at all the modules there, then we would publish data out of the adapters, and the tools automatically know how to look at any data coming out of the adapters. So we have adapters for XP, a database adapter, a schedule adapter for running schedule controllers, looking at temperature service or a statistic service where you can define new statistics, and all of the data coming out of that is exposed by the adapter. So that's the solution engine architecture. Now we have the solution builder, which is a development tool that enables the user to take a look at any of the data, analyze it, and then improve that hardware-software integrated system. Designed first for the non-developer. We knew that we needed to enable the maintenance personnel, the engineers and the managers running out there, and the operators with a tool, and that's really what it was designed around, because then it was that strong integration tool. It immediately offers a explanation and anybody's own view of what's going on within the system. It lives above an entire network of solution engines, so you can look at as many solution engines and combine them into one solution and have controllers coordinating those different things. Leveraging the REST interfaces from the solution engines prioritizes drag and drop. So you're just going to take your finger once you pulled off your glove and drag it to the screen and get the information that you're looking at or extend the controller that you're working on. Allows the user to develop collectors and models to analyze the process. Always prioritizing giving the user historical access to any piece of data. So if you want to look at a temperature and you say, I want to see that, if you've been collecting it, you want to see it over the last month, week, whatever, all of that information is immediately available in the tool so that the tool can also be an engineering tool to make decisions. And empowering the user at the same time with the ability through this drag and drop environment to create new rules and logic in the form of, we call them controllers, to directly improve or control the process. Solution Builder is a visual environment allowing you to take a look at things are grouped within the machine that you're working on, and then it might have some devices in it. It might have a machine that you're working on or a light that it's working on, and within those individual, like this machine, there's information about the parts that it's producing or the power that it's consuming, and as you click on those things, all the data items associated with them come down here to the tool. With those information, as you drag them out to the screen, then you can immediately start graphing things, graph multiple things, look at histories of information of any piece of data that you might try to pull out. You can build controllers with as many sequence of steps that you like and actions within them, define data collectors, and have all that visualized on as many screens as you'd like. Each operator may have their own screens the way they want to look at something, but that's Solution Builder and Solution Engine combining. Solution Builder architecture, like the Solution Engine, has a concept of having modules that are going to be plugging into it, and we'll see how it works. Again, it runs above .NET, but you can use .NET 4.0 in the Solution Builder architecture, and databases underneath it, again with a flexible storage mechanism, SQLite, SQL CE, and SQL or other mechanisms. We use the same IOC mechanism within Solution Builder that allows us to have services that talk to one another. And finally, the Solution Builder shell lives above that IOC. Its job is to load all the modules. Now, in this case, the modules and the services within Solution Builder are copy and paste, drag and drop. Those are basically infrastructure type things that we need to have happen. And create extension points where these individual modules can go in and stick in an alarms icon in the palette, or stick a controller into the palette that you might be working on and add to the toolbar. Again, we see the alarms controller displays. These are all the modules that have been loaded into here, and these can be all loaded by just putting them in a manifest so that they get loaded. So the architecture here is to have Solution Builder with all its modules there, and shadowing Solution Engine. So we see Solution Engine with its modules and its adapters over here on this side, and then we see all of the modules that have been plugged into Solution Builder. So the alarms module would then conceptually talk to the alarms module running over on the Solution Engine. Again, this blue line is what we think conceptually alarms actually talks to a REST interface and web server that's being published by the alarms module. So that's those links, and we can see controllers talking to controllers and schedule controllers, data collectors. So all of these using the REST APIs, which these blue lines represent, show how the solution family connects between the Solution Builder tool, again all over REST APIs, to be able to talk to the Solution Engine. So finally, we have taken a look at the solution family approach to defining new devices, intelligent devices, saying what that intelligence is, and providing the tools that allow either the user, the maintenance personnel, the operators, through developers and integrators, the ability to define what's going on in that device, and giving that engine an extensible architecture so that it can be moved and extended to different vertical markets. We enable process monitoring and understanding for improvements for any software-hardware integrated problem, and that creates and provides many challenges. And we think that the solution family of products uniquely provides an integrated approach to solving these problems with that robust engine and tools across a variety of vertical markets. I thank you very much for your time.